Hello students, welcome to the physics class of class 10. Our first topic for today is optical density. A medium of lower refractive index is optically rarer medium. The speed of light is higher in a optically rarer medium. A medium of larger refractive index is optically denser medium. Speed of light is slow in optically denser medium. Optical density is different from mass density of object. Important rule for refraction due to optical density of the medium. When light passes from optically rarer to denser medium after refraction, the light ray bends towards the normal. But as the light passes from optically denser to rarer medium after refraction, it bends away from the normal. Here in the diagram we see this is optically rarer medium and this is optically denser medium. When light ray passes from optically rarer to denser medium after refraction, we see the refracted ray bends towards the normal. This is the original direction of the incident ray. Here when light ray passes from optically denser medium to optically rarer medium, we see that the refracted ray bends away from the normal. This is the original direction of the incident ray. This angle delta is called the angle of deviation. This is the angle between original direction of the incident ray and the direction of the refracted ray. Next topic, refraction of light through glass slab. This is a practical example for refraction of light. We put a thick glass slab on paper and we make outline of this glass slab with pencil. We mark it as A, B, C and D. Then we remove the glass slab and draw this normal N dash. Then we take a particular angle of incidence with protractor and draw this line which meet at the point G. We put two board pins at the point E and F. Then we again put the glass slab in this position and try to see the two pins through the opposite side DC of the glass slab. We try to see these 2 points on the same line. Then when we see it, we put two board pins again on the point I and J, so that this IJ is on the same line with E and F. Then we remove this glass slab and join these 2 points I and J with straight line which meet at this DC line at the point H. Then we connect the point G and H. So we get incident ray, transmitted ray and emergent ray. This is the angle of incidence, this is angle of refraction, this is again angle of incidence and this is again angle of refraction. Next topic, these are the schematic diagram for the spherical lens. This is double convex lens, this is plano convex lens, this is concavo convex lens, this is double concave lens and this is plano concave lens. These are few examples of spherical lens. Important terms related to lens. First is center of curvature. The center of the spherical surface of which the lens is a part is called the center of curvature. Here in the diagram, C1 and C2 are the two center of curvature for two spherical refracting surface. Here in the diagram we see a convex lens and concave lens, both are part of two sphere. So this is one spherical surface, this is one spherical surface. So for these two sphere we have C1 and C2 as the center of curvature. Here also C1 and C2 are center of curvature for the two refracting surface. Next topic, principal axis. The line joining the two centers of curvature of a lens is called the principal axis of the lens. Here the line joining C1 and C2 for both the case is called the principal axis. Next, optical center. The geometrical center of the lens is called the optical center. It is denoted by O. Here in the diagram we see this point O is the geometrical center of the lens for both convex and concave lens. So this point is called the optical center. Next, radius of curvature. The two spherical refracting surface are the part of a sphere. So the radius of this sphere are the radius of curvature for the two surface of the lens, which may be equal or unequal. In the diagram, we see the distance between C1 and O is the radius of curvature for this surface, and for this surface the distance between O and C2 is the radius of curvature. Similarly, for convex lens also, the distance between O and C1 is the radius of curvature for this surface, and the distance between O and C2 is the radius of curvature for this surface. Aperture. The part of the lens from which refraction takes place is known as the aperture of lens. So the whole part of the lens is the aperture for the lens. Principal foci of a lens. Incident rays parallel to principal axis after refraction converge at a point for convex lens on principal axis and appears to diverge from a point for concave lens on the principal axis. These points are called the focus or principal focus of a lens. A lens have two focus for two refracting surface. Here in the diagram we see this is for a convex lens and this is for a concave lens. For both cases we see that the parallel incident rays after refraction meet at the point F1. Here also from the other side of the lens the incident ray parallel to principal axis meet at a point on the principal axis at F2. So this point F1 and F2 are the principal focus for two different refracting surface for the convex lens. For concave lens also we see that the incident ray parallel to principal axis after refraction appears to diverge from the point F1 here and appears to diverge from a point F2 here. This is two opposite face of the concave lens. So this point F1 and F2 is the principal focus for the concave lens. Next point, rules for the image formation. A ray of light from the object parallel to the principal axis after refraction from a convex lens passes through the principal focus on the other side of the lens. In case of a concave lens, the incident ray after refraction appears to diverge from the principal focus located on the same side of the lens. In the diagram we see for convex lens, incident ray parallel to principal axis from an object after refraction meet at the focus on the other side of the lens. For concave lens we see that the incident ray parallel to principal axis after refraction appears to diverge from the focus on the same side of the lens. Second point, a ray of light passes through a principal focus after refraction from a convex lens will emerge parallel to the principal axis. A ray of light appearing to meet at the principal focus of a concave lens after refraction will emerge parallel to the principal axis. In the diagram we see that for convex lens an incident ray passes through focus after refraction passes parallel to the principal axis, and a ray of light appears to meet at the focus for a concave lens after refraction it passes parallel to the principal axis. Third one, a ray of light passes through the optical center of a lens will emerge without any deviation. In the diagram we see for both convex and concave lens an incident ray passes through the optical center will emerge undeviated. Thank you for today.